recruit that later. Okay. So if you could, for me, what we're going to be doing is we're going to be looking at trig graphs, which you've already done. You've already looked at amplitude. Amplitude was the A value at the beginning of the equation, right? So if we have y equals A sine B x minus c plus d, if that's the form you have, right? You guys learned the last 2 days that this is your amplitude. Then you didn't watch the podcast. All right. Amplitude is the absolute value of A.
But she didn't give us that entire equation. She just said A sine B.
Yeah, the rest of
That's all we use. That's it all together. Just don't act like the rest isn't.
Oh, this is like on the f of x.
It's just like transformations. We're there. We reached it. Yeah, we're doing that today. We're going to do the transformations on it today. You have just come full circle. Good job. Okay. Amplitude is A. And then what you talked about yesterday or the last 2 days was the B value. And the B value got you the what? Do you remember?
Period.
The period. So if it was in radian mode, you would go 2 pi divided by B and get the period. If it was in degree, you'd do 360 degrees divided by B. Now, why the heck are we dividing by B? Well, that's the point of today's lesson, is to learn about transformations, to go about transformations and how the heck these equations come about. Now, we did look at the basic sine graph and we did look at the basic cos graph, right? On the last 2 days, you looked at what the basic sine graph was and what the basic cos graph was, and you learned how to graph it from the unit circle, I'm assuming. Okay. So, that's what we would have looked at. Now what we're going to do today is we're going to stretch, reflect, translate, all those things. Now, our B value in front, we went to transformations. We did the transformations unit. So our B value is this one here, correct? I'm pressing that. Why is it not acknowledging it? Our B value is the one in front. What transformation was that always? Do you remember? It's a horizontal stretch by a factor of?
1/2. Or like 1 over B.
Yes, 1 over B, right? So if it's a B, it's actually 1 over B. We agree? So we also learned that the basic sine graph and the basic cos graph repeat themselves every 2 pi or 360 because you draw them off of the unit circle. And the unit circle starts at 0 and goes to 360. You would sketch one period of the graph. 0 to 360 using all the x values, you sketch one period of the cos graph, correct? So it repeats itself every 2 pi. We agree? Or every 360. Well, what do horizontal stretches do? Do you remember?
Make them skinnier and wider.
They make them skinnier or wider because in mapping we multiply what? What values do you multiply your horizontal stretches by?
The x values.
The x values, right? So we're just multiplying our x values by that horizontal stretch. We agree? Okay. So if my original was 2 pi, and I had a horizontal stretch by 2, I would multiply by 2, and now it would be 4 pi. It would get larger. You don't have to write any of this. We're just revamping. We're just going back over why the heck 5.1 was the way 5.1 was. Okay? So if I horizontally stretched by 2, my period no longer would be 2 pi. It would be 4 pi. We agree? If I horizontally stretched by a half, my period wouldn't be 2 pi. It would now just be pi, because it would be half of that. We agree? So that's the reason why the formula works. I'm going to show it on a big screen over here. So if I have 2 pi, we're not writing this, we're just paying attention. I want you to understand why the heck the P formula works. So the P formula is 2 pi divided by B, right? That gets us our period. Well, why the heck does it work? Dividing by B, let's look at it. If we could write this out as 2 pi divided by B, could we not? And what do we do when we divide by a fraction? We actually multiply by the inverse. So what are we doing here? We're going 2 pi times 1 over B. And what is 1 over B just?
The horizontal stretch.
The horizontal stretch. So when we're dividing by this B value, the B value in our equation is just what the B value is. It's 2, 7, 9, 8. But what you're actually multiplying by when you're dividing by that B value is you are multiplying by the reciprocal. You're multiplying by the horizontal stretch. So that's why we divide by the B value. We don't divide by the flip of that. Because people don't know when they should flip or not flip all the time. Like when I'm doing this formula, When I use this formula, I'm not slipping my b value. Whatever my b value is, I just take it out and put it in there. Because when I divide by that b value, I'm actually multiplying by its reciprocal, which is the horizontal stretch. That's why that formula works. You don't even need to memorize the formula. As long as you know that a horizontal stretch multiplies by the reciprocal, that's what you're doing when you're using this formula every single time. That's all that is. So that's why the formula yesterday and the day before works. So let's look at this. Y equals sine x plus 3. Can you all type it into your calculator? I'm going to bring my calculator up. Because equations work better in radians. But it depends on our c value. Our c value will tell us what we're in. So if we go y equals sine x into our calculators, right? Then we go to mode. We can pick whatever mode we want. I'm just going to leave it in radian. Sure. Now what you can do if you're stuck and you're not sure what the heck to do to it, you can go zoom, trig, and it will at least draw you some sort of trig thing, hopefully, unless it's a word problem, which won't help you. But if you go zoom, trig, number 7, you'll get something showing up. Because your window has to be either in radians if you're in radian mode or degrees if you're in degree mode, right? So if your window is from negative 360 to 360, but you're in radian mode, it's going to look real ugly. It's not going to draw what you want it to draw because your window has to be in whatever mode you're in, right? But zoom trig will just stick it into the mode that you're in. So if you press degree mode, so here I press radians, right? Let's go like this. And I press graph because I'm in radians. If I go, don't do this. If I go to degree now and I press graph, it's going to fight me, right? Because this is actually between negative 2 pi and 2 pi, which is 3.14. So it's now drawing you a graph between negative 3.14 degrees and 3.14 degrees, which is really tiny, right? So if I wanted to fix it, I could just go zoom, trig, and now it'll switch my window to degree mode. So if you're stuck, that's not the be-all, end-all. It's not the always fixed, but it could possibly get you to draw something that you're in, right? The mode you're in. Okay, so that's my sine x graph, the basic sine x graph. I told you to put in sine x, close your bracket, plus 3. Okay? If I don't close the bracket, that 3 is with the x, isn't it? Do I want it to be with the x? No. If the number's at the back in any transformation lesson that you did, what does that number do? The number at the back. Yeah. It would be in some instances, but not. Yeah.
It's like a translation.
It's a translation. It's a vertical translation. In trigonometry, it's called vertical displacement. It's the only unit that they call it something weird. It's called the vertical displacement. So if you have the fancy colored calculators, great. Mine's going to show up in 2 colors. If you don't have the fancy colored calculators, you can arrow over to this slash line over here and hit enter once. If you have the fancy colored ones, don't even do it. If your screen is different colors. If your screen doesn't have different colors, then go over here and hit enter once and it'll make it thicker. So your first line, your first graph will be a thin line, and your second graph will be a thick one. And you can press graph and it'll show it for you.
Yeah, honestly.
So, do you have it typed in?
Yeah, it's just not. It's not drawing a graph.
Did you do zoom trig?
No, I don't. I might just. I did.
What happened to the graph? It moved 3 up. That's all it did. Correct? Did the period of the graph change? No. Is the graph still repeating itself from here to here? Or here to here? Is it still repeating itself from here to here? Here to here? Yep. Did the period change? Nope. Okay. Did my amplitude change? The amplitude is half the distance from the min to the max.
No.
Is this any taller? No. My amplitude didn't change. Okay. Did my x-intercepts change? Yeah, this one had x-intercepts, this one doesn't. Okay. Did my y-intercept change? Yeah, it's moving all my y's up 3. Right? With mapping, all my y's moving up 3. Did my domain change? It's XER. Did my range change? Yeah, my graph goes from here to here. It's now way up here, isn't it?
Yeah, it's 2 to 4.
Yeah. So let's go through here. Okay. let's talk about this. Did my amplitude change? Did my amplitude change? No. We can base it off of our equation. Every single time I go to write out my equation, I'm going to do this. I'm going to go y equals 1 sine. What's my b? My b falls between my sine and my x. Well, it's a 1. And then I have x plus 3. Do I have it like this? Does it go in the bracket? Nope. So I'm going to have x and then a plus 3 at the back. What's in here with the x? If there's nothing in here, what's in here? If there was a 1 would exist. It's a 0. So if there's nothing with the x, it's just a plus 0, correct? So I'm just showing all the differences. A is A, B is 1, C is 0, D is 3, right? It's just showing all the A, B, C, Ds. That's all I'm doing. Now, you guys learned that the absolute value of A is the what? Amplitude. So the absolute value of A here is 1. What's the absolute value of A here? 1. That's why the amplitude didn't change. My amplitude's 1, it stayed 1, right? What's the only thing that's going to change in amplitude? What makes your graph go big or short? Vertical stretch. Where is your vertical stretch found? At the front. That's why your amplitude is your vertical stretch. It's just stretching. Your graph's normally 1, 1. The radius of a trig graph is 1, 1, right? Because the radius of a unit circle is 1, 1, right? Negative 1, 1. So my amplitude's half that, so my amplitude's 1. The only thing that's going to change your amplitude is if you pull it up higher or shrink it, which is your vertical stretch. That's why your vertical stretch is your amplitude. That's all it is. Vertical stretch is your amplitude. That's it. So let's talk about this. Do we have a vertical stretch? No. Do we have a horizontal stretch? No. Do we have a horizontal translation, which is actually called the horizontal phase shift in trig? No. Do we have a vertical? Yes. So we have a vertical displacement is what it's called in trig. Don't ask me why. It just is. 3 what?
Units up.
Units up. Then I want the mapping. So my coordinate x, y. Did anything happen to my x's? No. How do I know? Is there anything happening in that bracket? No. If this bracket is a 1 and a 0, my x is x. I have no horizontal stretches. I have no horizontal translations. My x is not affected, right? Is there a vertical stretch or a reflection? Nope. So I'm multiplying my y's by 1 or nothing. And then I'm going to do what to my y's? Add 3. That's it. So I can draw every single sine graph from the original sine graph if I want to, just using mapping, can't I? Take the original points off the sine graph, plug them into mapping, boom, 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 I have my equations. Right? I have my graph. Did my amplitude change? No, I'm not circling it because it says circle what's changed. Did my range change? Yes. Yeah. Only because the whole graph, I took the whole graph and I just did what to it? I just pulled it up through, right? So my range changed. Did the period change? Did anything happen to my x's? No. No. The period of the graph is affected by my x's. The period of the graph is actually affected by my what? What's the only thing that can make it wider, which makes the period take longer or shrink it?
Horizontal stretch.
Horizontal stretch. My horizontal stretch is the period of the graph. It helps get the period of the graph. You should multiply by it, right? Which we were dividing by the b yesterday. Same thing. So the period and the domain are not going to change if nothing's affected to my x because it can't shrink it or narrow it. It can't make my domain happen faster or slower. X-intercepts. Did they change? Yeah, the whole graph got lifted off. Yeah, there are none, actually. It got changed so much, they're gone. Is the y-intercept changed?
Yes.
Yeah, I'm doing a plus 3 to all my y's. My y is 0 and something. Now it's 0 and something plus 3. Right? That's all it is. The sine graph is 0, 0, so now it's going to be 0, 3, because I'm taking that point and moving it up. I can use mapping. Right? So you can always move your y-intercepts really easy. On a sine graph, it's 0, 0. Plug it into mapping, you have your new y-intercept. Right? Okay. Quick way to get your range without using your calculator. And the reason why it's not good to use your calculator is because sometimes they put variables in here instead of numbers and you can't plug it in. That's the great thing about 30-1. They use variables. It's great. And by great, I mean sucks. is that they'll put variables in, and then you can't plug it in, and you can't go second trace max, left bound, right bound, get your max, second trace min, left bound, right bound, get your min, right? You can normally use your calculator, get those babies, and you got your range, right? But what happens if they give you variables instead of numbers? Well, we can always use the same thing. Let's think about this graph. I'm going to go on another page. If I give you a graph like this, you don't have to draw it, we're just paying attention. And this is the graph. Pretend that's connected. Okay, we have a midline. Pretend this is actually symmetrical too. This is a pretty crappy graph. But we have a midline, right? Do you know where the midline comes from? The graph that cuts, the line that cuts the graph in half. Do you know where that comes from? Yeah. It's just in between the maximum and the minimum. It's just the average. It's your d value. I saw her draw it. So it's y equals d. Whatever the d is of the equation. So in this case, what was it? It was 3, wasn't it? Now, if I have that d value, what else do I need to get my maximum? What do I need so that if I add it to it, I get my max? What is this? Middle of the graph to the top. Yeah. It's just your amplitude. So if I take my midline and I add to it my amplitude, will I not get my maximum? Okay. What about if I want minimum? Just subtract your amplitude from your midline, correct? So you can do that every single time without having to type into your calculator at all. So let's go back here. So I'm going to write myself a little helpful hint. If I want the maximum, what did you tell me I could do? I could take the middle of the graph, which is the midline, which is what variable in your equation? It's your d. And I could add to it my what? My amplitude. And what's my amplitude off my equation? Close. Absolute value of A. So if I go D, my midline plus my amplitude, which is the absolute value of A, I get my maximum. Right? You just saw that. And my minimum is just I take my midline and I subtract my absolute value of A. I subtract my amplitude. If you do these the wrong way around, you will get it wrong. And if I were the person writing your test, I would put that as an answer, because that would be common error, putting them the wrong way. Okay? Okay. Range, it's sandwiched between two values, isn't it? It's always going to be sandwiched between two values. So your range is always going to be in set notation, squiggly bracket, curly bracket, whatever you want to call it, y such that, straight up and down line is such that. And we always start with our minimum. And it's less than or equal to my y, which is less than or equal to my max, y-er. And the reason why these are in the exact same order, they're both less than looking signs, is because you read from the y, right? So this is y is, it's open, so it's y is greater than or equal to my minimum, and then y is less than or equal to my maximum. That's why they're always in the same L's, slanted L's, min to max. Now, if you get the interval notation, if someone nicely says interval notation, throw a party, because all it is a square bracket minimum, comma, maximum square bracket. Because it's equal to the min and the max, and it's squished between them. Right? Interval notation is the easiest in this one. So let's go to this question over here. It says, how could the range be obtained without the graph? I don't want the graph. I just want to be able to get the range from this equation. Not from going to my calculator and finding the max and the min. How would I do that? What would the maximum be in this case? What's my D? 3. What's my A? 1. So it's the absolute value of 1, which is redundant, but nonetheless. 3 plus 1 is 4. Boom. Okay. My min is the D value, my midline, 3. Minus the absolute value of A, 1, and it's a 2. When you look at the graph, it's 2 to 4, right? So we're right. What's the distance between 2 to 4? It's a distance of 2. What's my amplitude of this graph? It's a 1. And then 1 plus 1 is 2, because amplitude's half the distance, right? So when you find your range, you should be able to take your amplitude and times it by 2, and it should be the same distance, right? It's like a double check. So how do I do my range? it's going to be y such that 2 is less than or equal to y is less than or equal to 4 YER in set notation, or an interval, square bracket 2 comma 4 square bracket. Which one's better? Whichever one they ask you for. That's it. Neither of them is actually better. In calculus, we don't do set notation anymore. They go to the interval. That's why we work our way through intervals, because in calculus they just do interval notation. But in 30-1, both can be asked. Okay, what's the period of this graph? Did it change? No. What's the period of a normal sine graph? 2 pi. And this one's still 2 pi. Why? We can use our formula. The period is 2 pi divided by b. What's b in this case? 1. So there's no horizontal stretch. There's no horizontal stretch. That means my graph's not getting wider and it's not getting narrower. It's staying just where it was, which is 2 pi. Nothing changed, right? So if I don't have a horizontal stretch, what is my period going to be? 2 pi if it's in radian mode, or 360 if it's in degree. The only thing that can change your period is your horizontal stretch, because it can make it wider or narrower. That's it. That's all. I can add a vertical stretch, a reflection. I can add a reflection to the y-axis. I can add a horizontal phase shift, and I can add a vertical displacement. And the period will still stay 2 pi, because the only thing that can change it is something according it, squishing it in or pulling it up. So let's look at number 2. Cos graph. So type into your y1 cos x, type into your y2 cos x minus 2. Just like we suspected, what happened to it? Moved down 2. Vertical displacement is the fancy terminology we're going to use. Did it squish it this way? Did it squish it this horizontally? No. Did it squish it vertically? No, there's no vertical stretch. There's no horizontal stretch. So my amplitude's still going to be what? 1. My period's still going to be? 2 pi, or 360. The b value will still be 1. That's true. Okay. So let's go through here and let's state what we have. So what I always do for my own health and welfare is I rewrite this out with the A, the B, the C, the D. If there is no A, it's 1. If there is no B, it's 1. If there is no C, it's 0. If there is no D, it's 0, right? Because stretches multiply and the translations add. So here we're going to get y equals 1 cos 1 x plus 0 minus 2. If you don't want to do that, you don't have to. It helps me out because I see that there's no changes in a lot of places. This graph is literally just moving 2 down, right? So what are my transformations? Vertical, translation, to, yeah, translation. Come on, Lepp, grab a minute. You just taught that and then wrote translation. Vertical displacement. Two down. And you know your transformations have to go stretches, reflections, translations, right? Your order matters. There's just nothing else to write, so we can write that. What's our mapping going to be? X comma y becomes x comma y minus 2, because if I'm moving it 2 down, I'm moving my y's 2 down, so it only affects my y's, right? Did the amplitude change? No, the amplitude in the first one is 1. In like your cos graph is 1. Your amplitude here is absolute value of 1, so it's 1. That didn't change. Did the range change? Took the graph and I dropped it down 2. Is that going to move my range? Yep. Did the period change? Only way the period changes if there's a horizontal stretch. Is there one? Nope. The domain is affected with the period? Nope. X-intercepts. Yeah, once again, they move. What about the y-intercept? The y-intercept of a cos graph is 0, 1. I'm now dropping it down 2. So is it going to move? Yeah, it's 0, negative 1 now. What's the range? How do I get my maximum? What's my midline? What's the line that cuts the graph in half? Y equals E, which is -2. So I'm starting at -2. That's my middle line. My middle line's at -2. And then I'm going up an amplitude of, what's my amplitude? 1. So I'm starting at -2 and I'm going up 1. So it's going to be at -1. And my minimum, I'm starting at a midline at -2 and I'm going down 1. Where's it going to be at now? -3. You should be able to visualize. Don't memorize. Memorize is scary because memorizing means you can oopsie it. So -2 minus 1. Now I could go minus absolute value of 1, but it's a positive. It only really messes up if your A is a negative, right? You have to watch yourself. So it's at -3. It also only messes up if you don't understand it. If you know that you're going to go at your midline and you're going to subtract your amplitude and add your amplitude, do you need to memorize anything? No, you just understand it. It'll make it a heck of a lot better. So my range is going to be y such that -3 is less than or equal to y is less than or equal to -1 yer, or the best thing in the world since sliced bread, -3 and -1, interval notation. What's the period of this one? Do I need to use the formula? Do I need to use the formula? No, you can use your knowledge. Your knowledge knows that it's 2 pi, and the only way it's changing is if there's a horizontal stretch. Is there one? Nope, so it stays the same. Can you use the period? Can you use the period formula? Absolutely. 2 pi divided by, what's my b? My b is a 1, so it's 2 pi. Okay? Okay, we're going to do number 3 together, and then number 4 you're going to try, and we're just going to keep doing that. Number 3, what's my change? Yeah. There's an A value this time, which means what's changing? My amplitude. I'm vertically stretching this baby. It's at -1, 1, and I'm taking it and I'm going, shook. I'm pulling it by 3, aren't I? That's all I'm doing. And then I'm like pulling it by 3, and then I'm going, and now I'm moving it up 2. So now it's just up here. That's all that's happening, right? Nothing crazy. So I'm going to rewrite it with filling in my C's and my B's because I don't have any, and I like having them all. So y equals 3 sine bracket 1 x plus 0 plus 2. Okay? So what are our transformations? By a factor of? About the x-axis. So it's about the opposite axis. So vertical stretch by a factor of 3 about the x-axis. Is there a horizontal stretch? No, my B is a 1. Is there reflections? No, my A and my B are positive. Is there a horizontal phase shift, which is the C value? You haven't learned that yet. Nope, it's still 0. What's the only thing that's still here? D value. So it's a vertical displacement, 2 units what? Let's do our mapping. Is anything happening to that x? Do we have anything going on in here? Nope. So I know it's going to be x, y becomes x. And everything's happening to my y's because there's nothing happening to my x's. What I'm going to multiply my y's by? 3, and then I'm going to do what to it? Add 2. Could I not just take the basic coast graph and then just do mapping to it and get myself a new one? Yep. Because they could give you the coast graph and make you draw it. Now, did my amplitude change? Yeah, my amplitude was a 1 on the basic coast graph. It's now 3. So it's actually way taller, way longer, right? The graph. So my amplitude changed. Did my range change? If my amplitude changes, my range changes. It's going to happen. It's going to, like, even if I don't shift it, it's taller, right? So my range is going to change. Did the period change? The only thing that affects the period is the what? Horizontal stretch. It accordions it. It squishes it in or pulls it out, right? Is there a horizontal stretch? No. So the period and the domain aren't going to change. Did my x-intercepts change?
Yeah.
Only because I moved up 2. My x-intercepts wouldn't have changed if just the amplitude changed. If just the amplitude changed, it would be pulled up, right? Which would mean all of my y's got multiplied by 3, doesn't it? What are my y's on the x-axis? What are my y's on the x-axis?
0.
0. When you multiply 0 by 3, what happens? Nothing. So if you have, this is a trick that happens sometimes last, if you have just a vertical stretch or just an amplitude change, your x-intercepts do not change. Because you're multiplying those, which are 0, by 3.
So you need both the amplitude and the...
You don't need an amplitude even at
or-
all.
Yeah.
All you need is shifts.
Okay.
So anything but this. This is the only thing that if it's by itself won't change your x-intercepts, right? Horizontal stretch will change them. It'll squish it or move them around. Horizontal shift will. Vertical shift will. The only thing that won't change x-intercepts is if you have just a stretch by itself. Because you're multiplying all your x's by a number, but your x's are all zeros. Right? Or your y's by a number, but your y's are all zeros. So your x-intercepts change. Does your y-intercept change? Yeah, a whole bunch of stuff's happening to some y's here, right? So it's going to change. Okay, what's my maximum? Where's my midline at? Y equals 2. It's at y equals 2. And then I'm adding what to it? No, what's my amplitude? 3. I'm adding the absolute value of 3, which is still 3. So I'm getting 5. I have a midline at 2, and then I'm going up 3 from it, right? So now it's at 5. I have a midline of 2, and now I'm going down 3 from it, so it's going to be at what? Negative 1. You can visualize it. I literally put my arm out all the time to help myself. So I go 2 minus the absolute value of 3, and I get negative 1. What's the difference, or what's the distance, sorry, between negative 1 and 5? 6. What should it be? It should be 6, right? Because it should be 2 times the what? The amplitude. What's the amplitude? It's 3. So you know you're at least possibly good, right? So my range is going to be y such that negative 1 is less than or equal to y is less than or equal to 5. Y, E, R. Or negative 1 to 5. Square bracket. What's the period? The period change? Did the period shift? Did I accordion this thing? Did I pull it out or squish it in? Nope, because there's no horizontal stretch. So what's the period going to be? 2 pi. It'll be 2 pi divided by 1, which is 2 pi. Right? That's the reason why it's not changing. I can show you it with the formula. It's 2 pi divided by b, which is 1. So it's 2 pi. Okay? You're doing number 4. Try it out. It's the hardest one? Is that what you said? It just has a negative in front. Okay, so I would rewrite it myself, preferably as negative 2 cos bracket 1 bracket x plus 0 bracket minus 3. So what do I have for transformations? Vertical
Stretch
by
factor 2
about the,
x.
yeah. Vertical stretch by a factor of 2 about the x-axis. What else do I have? Anyone know? Mm-hmm. I say reflection in, reflection on, same thing, whatever you were told, just write it. Even reflection about works. There are some like reflection arounds, they do not work. You lose marks on the diploma if you write like around. So stick to what she told you. And then you have a vertical displacement.
3 units down.
Nope.
Oh, 3 units down.
There we go.
Sorry, I was looking at the other thing.
3 units down. Is my amplitude changed? My amplitude changed? It's normally 1, it's now 2, not negative 2, 2. So my amplitude changed. Did my range change? The moment my amplitude changes, my range changes. The period, did it change? No, no horizontal stretch. Did the domain change? No, what about the x-intercepts? Yep. What about the y-intercepts? Yep. What did I forget to do? Mapping. Okay, good. X, Y. Did anything happen to my x's? Is there anything sitting in this bracket? Nada. So the x is going to stay, and the y is going to get multiplied by and subtract 2. 3. What is the range? Well, let's think about it. What is my midline? Where does my midline happen at? Y equals -3. So I'm sitting at -3 horizontally here, right? That's the line that's cutting my graph in half. And then what's my amplitude? 2. So I'm going to go up 2 from -3. So where am I going to be at? -1. And then I'm at -3, and I'm going to go down 2 more. Where am I going to be at? -5. So my maximum is my d value, which is -3, plus my amplitude, which is the absolute value of -2, or you can call it the vertical stretch, whatever you want. It's going to be at -1. And my minimum is going to be -3 minus the absolute value of -2, which is -5. What's the distance between those? What's the distance between those? -1 and -5. 4. What should it be? It should be 4 because what's the amplitude? 2, and it should be twice the amplitude, which is 4. So we double checked her. So we're going to have y such that -5 is less than or equal to y is less than or equal to -1. Y are -5 and 1. Did the period change? No, why? There's no b, there's no horizontal stretch, there's no accordion happening. It would be 2 pi divided by 1, which is 2 pi. Okay, we're going to flip over. That is not what you're on. That is not what you're on. This is what you're on. There was like one thing added, and it's like life. Oh my God.
Yes.
We're literally just shifting it right or left. That's all we're doing right now. Like nothing crazy going on. Okay. What's my axis in? Yeah. Sure. What's my axis in? Not use the bathroom. What is my axis in? That was funny. No one laughed. It's fine. It's good. What's my C value in? Look at the C. Look at the C. It's in radians. So what does this equation have to be? Oops. In radians. So what your C value is in is what your graph has to be in. If your C is 0, you have a choice. You could go radian, you could go degree, unless they ask you specifically, right? But if your C value is radians, this graph's radians. You have no choice. So you see the C value here? This is a radian measure, isn't it? And I'm lazy, so I'm going to put a 1 here, and I'm going to put an extra bracket, because I don't want to rewrite it. Sheer laziness. Okay? So my A is -1/3. My B is 1. My C is actually what this time? What's my C? C. What's the C? It's just pi over 2. It's not the negative, right? Because remember we have x minus c. So c is what's beside the minus sign. So it's always the opposite, and we know that. It just sometimes tricks us if you ask for c. If I ask you for horizontal shift, you'd be like, boom, I got this. I know it's right or left. When you ask for the c, it still follows the same rule. So the c in this case would be pi over 2, and the d would be 2. So what do I have here? I have a vertical stretch by a factor of what? One-third, not the negative, right? About the x-axis. It's not the negative because the negative is the reflection, right? Our vertical stretch is always positive. Do I have a horizontal stretch here? You only have a horizontal stretch if you have a number that falls between cos and x, and I don't. It's just a 1. So I don't have a horizontal. I have a negative in front, so what's that? The reflection in the x. When it's with the y, it's always about the x in the x. When it's with the x, it's always about the y in the y, right? So we have a reflection in the x-axis. If you say, do you guys use on or in? I can adapt. What did she tell you to do? Reflection? On? Did she say on or in, or what did she say?
She said across.
She says across?
Yeah, it's like in, yeah.
On, in, and across are all okay. If you say across.
You say over.
See, this is when it starts getting dicey. In the textbook, it says in. On is fine. And across, which ones does she use? Across? Then use across. It doesn't really matter. On or across? On, reflection on the x-axis. She uses across. I use in. Both of them are acceptable. We have like a list when we go to mark. I'm not joking. There's a list of like acceptables, and then there's a list of like not acceptables. She used across. That's fine. I just want to use whatever she uses, so we keep it consistent. It's across. There's like literally 10 words that are acceptable, and then there's like 800 extras that kids write that are not acceptable. You're not in that boat, so you're okay. Don't make your own up. Don't be like a reflection surrounding or something. Don't do that. Okay. We get weird things. You have no idea. Okay, reflection across the x-axis. And then we have... My brain has halted. Okay, we have a horizontal phase shift. It's weird. It's written like that. I don't know why. You can enjoy it. It's a present. Horizontal phase shift. It's a gift only you get. And every other 30-1. Horizontal phase shift, pi over 2 units, what? Right, it's always the opposite. Hasn't changed in trig. Always the opposite, always the opposite, always the opposite. It's a great thing about transformations. Once you have them down, it's literally the same. It doesn't matter what weird function I hand you. And then a vertical displacement. Vertical displacement, what? 2 units up 2 units, same thing, different pile. They'll accept any of those variations too. What was the one that I think they used surrounding? That was the one we were like, what is that? I think you just forgot totally. On, in, across, all work. Okay, 6. Nope, we are not done. Why am I moving on? Okay, x, y becomes what? X plus pi over 2, yeah. It's the only thing in the x bracket, right? And then this multiplies my y's, adds my y's. So negative 1/3 y plus duh. Did my amplitude change? Yeah, it's squished. It used to be like 1 and 1. It's now like, because it got multiplied by 1/3, didn't it? So it's like a little wee graph. It's gonna like be super tiny. You should expect it. It's great. Okay, so it's gonna be a little teeny tiny graph. Amplitude change. Did my range change? If it's normally 1, 1, and now it's squished. Yeah. What about the period? Did it change?
Yes.
No. What is the only thing that makes that period happen more or less? The b value. Did I get a b value yet?
No.
Next one I'm going to, so it's going to change. Just an FYI. So b value did not change. Period didn't change. Domain didn't change. X-intercepts? Yeah. Y-intercepts? Uh-huh. What's my range? Well, my maximum is my d, which is 2, plus my amplitude, which is 1/3, which gets me 7/3. That's the value of negative 1/3, sorry. And my min is 2 minus negative 1/3, which should be 5/3. And the difference between that is 2/3, which makes sense because my amplitude is 1/3 times 2, 2/3. My range, y, such that 5/3 is less than or equal to y is less than or equal to 7/3 y ER. 5/3, 7/3. And the period is 2 pi divided by b, which is 1, so it didn't change. And I had to use 2 pi. On the other ones, I could have actually used 360 degrees, and I still would have been fine, because the c value didn't exist, right? I didn't know if it was in radians or degrees, and I didn't specify, so I could have used 360. This one, because my c is in pi over 2, I have no choice. What about this one? My c is what? Degrees. So my period's going to have to be 360 degrees, guys. 360 degrees divided by b. Because my c value makes this equation in degrees. What's the first thing we have to do for this baby? Yeah, we have to take out that b. So we're going to get y equals 1 sine a half theta minus, what's 15 divided by a half? 30. Remember when your GCF, when your B value is actually a half, your C value gets bigger? When your B value is a fraction, your C value will get bigger. If it doesn't, you're oopsie. Because you're dividing by a half, which is like multiplying by 2. And your calculator will do it for you. And it's expensive, so you might as well use it. Okay? 15 divided by a half, to check yourself, is going to be 30 degrees plus 0. There's an extra bracket. There it is. So you're going to try 6 and 7. Okay, so we have no vertical stretch. Never mind. So we have a vertical stretch. Nah. We have a reflection. Oh, vertical stretch. No. Okay, so we have a horizontal stretch by a factor of what?
1/2 or 2.
There we go. Factor of 2. There's an oven there, just pretend it. About the opposite O's axis. About the, it's with the X, so it's about the y-axis. Thanks. Your answers were also great. And then we have a reflection anywhere? No, there's no negatives. Do we have a translation displacement at the back? No. We have a horizontal phase shift. Right. 30 degrees. Right. If you don't put the degree symbol, it's actually radians and you're wrong. Wouldn't that suck? That would suck. Okay. Mapping. X, Y becomes, absolutely nothing happens to my X's, or my Y's. They're sitting out there, so I'm just going to go Y. And then this is going to be 2x plus 30 degrees. Don't forget the degree symbol, or it's radians. Did the amplitude change? No, it's 1. It's still a 1. Did the range change? It was at 1 and 0. No, it didn't change. What about the period? Yes, there's a B value. What about the domain? The domain is XCR, so really it doesn't ever change because it just keeps going on for life. So no. X-intercepts? Yes. Y-intercept?
Yes.
Yes, because you're moving at 30 degrees over. Okay, my range is going to be Y such that my minimum, so I'm at 0 and I go up 1, 0 and go down 1. So it's -1 is less than or equal to Y is less than or equal to 1, YER. Or -1 and 1. And then the period?
720.
Yeah, it's normally 360, but I'm stretching it by a factor of 2. So I can either use the formula and go 360 divided by a half, which multiplies by 2. Or I can go, hey, it's 360 and I'm horizontally stretching it by 2, so I'm going to multiply it by 2. So what's that? 720, same thing. This one, 1 plus 0, I have a horizontal stretch by a factor of 1/3 about the y-axis. It's always about the opposite. And a horizontal phase shift pi over 2 right. My amplitude's 1, it's still 1. Nothing. My range is at -1 and 1. Nothing. My period? It's been multiplied by what now? 1/3 or divided by 3, so it's going to change, right? So the period's going to change. Domain, we don't worry about it. X-intercepts are going to shift. Y-intercepts going to shift. So my range, my maximum is my D, which is 0, plus my amplitude, which is 1. So 1. My minimum is at 0. I subtract my amplitude, which is 1 from it. So it's at -1. So my range is -1 is less than or equal to what? It's less than or equal to 1. YER. Or -1 to 1. And the period, you can either go 2 pi divided by B. B is not the horizontal stretch. right? The horizontal stretch is 1 over b. So if it goes 2 pi divided by b, it's literally what b is. So it's 2 pi divided by 3. Or you could say, hey, the period is 2 pi, and I'm going to actually multiply it by the horizontal stretch, which is 1/3. So it's 2 pi over 3. That's why it works. But you just multiply your period by the stretch. Yeah.
So this one got narrower, and then this other, like 6 got wider.
Yep. 6 would repeat itself normally in 360. Now this little curve thing is going to go. The other one was 2 pi. It's now 2 pi over 3. So it's going to go faster. So A represents the vertical stretch. Oh, keep up. Okay. Or the absolute value is the amplitude. B represents, well, it also represents a reflection technically. I'm just going to put it there. B never is negative, so B represents the horizontal stretch. But it's a horizontal stretch of 1 over b, right? The period of the graph is found by using b in the formula 2 pi over b, technically absolute value of b, or 360 and the absolute value of b. C represents the horizontal phase shift. The equation must be in the form must be in the form, I'm being lazy. It must be in that. You must have your B out, right? Every single time the B has to be pulled out, GCF, B has to be pulled out, B has to be pulled out. D represents the vertical displacement. It's also my midline. I'm going to put that too. And the range can be found by y such that my minimum is less than or equal to y is less than or equal to my maximum, YER. My max is D plus the absolute value of A, and my min is D minus the absolute value of A. Then we're going to flip 2 ahead. Trying to squish a big lesson into a small time slot. Flip 2 pages ahead. So you're on the back, basically. Page 4. On the back, it just says determine the equation given the characteristics. So we're going to do one example 3 and one example 4. So example 3, it's a sine graph. It has an amplitude of 2. Where does that go? In for what of the equation?
A.
The A. So it's a 2. Sine. Now, does B equal P in the world of letters? Honestly, does B equal P? Could you call it like Paula? Could you call her Bala and it would be the same name? No, that's not true. So B doesn't equal P. So the B value doesn't equal the period, and the period doesn't equal the B value, right? B doesn't equal P, P doesn't equal B. It's not possible. So people will go period of pi, and then they'll go put a pi in for B. Can I do that? No, that's what P equals. P equals pi, correct? So P equals 2 pi over B. These flip-flop. B equals 2 pi over P. So if they give me P, I just have to plug it in there, and I get B. So my B in this case is going to be 2 pi divided by the period. And what's the period? Pi. So what's my B? 2. Never put your period in for the B. They are not the same. Then you're saying B equals P and Paula could be Bala, and she can't be. She didn't want that. That would suck. So, sine 2, horizontal phase shift, pi over 3 left, x. Do I add pi over 3 or subtract it? Add it to go left. Bracket, bracket. Vertical displacement 1 down, minus 1. So the biggest tricky one here is the P can't be the B and the B can't be the P, right? You actually have to find the B. It's a step. This one down here, we're going to do the graph of y equals cos x is transformed as described. Just determine the transformed equation in the form y equals a cos b x minus c plus d. This is literally testing transformations. That's all it's doing. So, vertical stretch by a factor of 1/3. I'm going to get a 1/3 in front. Horizontal stretch by a factor of 2. It's going to go in as a what? 1/2. Horizontal phase shift 30 degrees right. I'm going to take a bracket and I'm going to go x minus 30 degrees. That's the only way I can go right. Close bracket, close bracket. Vertical displacement 5 down. Minus 5. So it's just transformations. That's all that is. If you're good at transformations, those will be easy questions. If you're kind of still oopsieing, they're a little harder. Okay? That is your homework. It's 1ABD or 1BDE. Now this is the catch. It says to sketch them all. That's insanity. So sketch D. This is 2BDE, sketch D. And then 3, 4, 5, 6 AC, 7 AC. 3, 4, 5 is matching, so it looks like it's not like one with like A to Z and then you have to do all of them. I think it's like A to D, but they're matched. Like you match the graph with the equation, match the graph with the equation, stuff like that. Match the graph with the words. It's a matching. This one, and this one. So that's your homework. That's going to go in your folder thing. Do okay? Thing. Book. It's a book. It's going to go in the book.